Well, that's good news. Hi there, welcome back to the S3-1200 video series. In this video series, we're documenting our process building a modern version of the EMU SP-1200 using the ESP32S3 microcontroller. In the last video, I showed you how to do some schematics and PCB design in KiCad, and we took that design and we sent it off to PCBWay, and they've produced a PCB, an actual PCB for us. So in this video, we're going to focus on the physical board. We're going to be soldering our components on, we're going to be attaching heat sinks, we're going to be taking some measurements to make sure it works. Hopefully it works. And yeah, that's about it. So I got the box here in front of me. Let's crack it open and see how it turned out. Here we go. The box looks fantastic. Very clean. Oh boy. Well packaged. Lovely. Here's the shrink wrapped PCBs. I got 5 of them. Well, just want to give a quick shout out to PCBWay for sponsoring this video. They made the power supply PCB that you're seeing here. And honestly, initial reaction, the quality is fantastic. The solder mask is perfect. The silk screen is super sharp and there's like no rough edges at all. It looks awesome. Whether you're starting a new project or working from an existing design, PCBWay has got you covered. Prototyping, assembly, CNC, 3D printing. At the time of recording this video, PCBWay is about to launch a Christmas sale from Black Friday through December 28th with massive site-wide coupons, free specialty inks like purple, matte black, and pink, plus 10% off materials like UTR 8100 and Somos Ledo. So if you need boards made just like this, check out the link in the description. Okay, cool. So this is all the stuff that we need to solder. I've got my soldering iron fired up and I've got my sponge moist. I've got my lead-free solder. I've got some flux just in case we need it. I've got our breadboarded power supply here. I'll be removing the components as I go and soldering them on here. I've got some needle nose pliers here just to kind of straighten out some of the leads that are bent already, and some side cutters. From my experience, the easiest place to start is with kind of like the smallest components first, like the ones that are going to sit closest to the board. So in our case, it's the 1K resistors. So here's a 1K resistor from our breadboard. The leads are already bent. In our case, we're going to find a part labeled R1, and we're going to place the component in the spot. Now remember that resistors are not polarized devices, so it doesn't matter which way you put them in. And then what I'm going to do is I'm going to kind of just hold the resistor in place as I flip the board around, and I'm going to kind of bend the leads a little bit like so that it stays in place. Okay, and I'm going to do that with the other resistors as well. Okay, cool. And now we can just solder them in place. So all you're going to do is flip the board around, grab your solder, and we'll wipe off the tip on the sponge. You can use your little steel wool if you like to get it nice and clean. And then all you're going to do is place the tip right on the lead and the pad at the same time and add a little bit of solder. Okay, now we can trim the excess. So next we're going to place our rectifier diodes. There's 2 different kinds of diodes on this board. One is a 1N5392 diode and the other is a 1N4004 diode. And one thing we have to remember is that diodes actually have polarity, right? So they have to be placed in a certain way. So I'm going to grab a 159392 diode. So as you can see, the diode has a stripe and so does the silk screen. So we want to make sure that those stripes are lined up. The leads are already bent, so just like so. And again, you want to bend the leads so that it kind of like holds in place like that. Okay, so I'm going to do that for all the diodes on this board. Sometimes like this diode here from the bending it in the breadboard, you can straighten it out with the needle nose pliers, so it makes it slide into the PCB a little bit easier. Okay, so here's our LED, and as you can see, the LED has two leads on it, and on the PCB, there are two different pads on here. One's a circle pad, one is a square pad, right? Because the LED is a polarized device, that tells us which lead goes into which hole. Looking at the LED, you can see that one lead is longer than the other, so the anode is the long one, and the cathode is the short one. So we want the short one to go to the square, and the long one to go to the circle. Now for the negative 12 volt rail, I've decided to go with a green LED, just so that I know that it's a different voltage. So here's the ceramic capacitors. They're just going to slide right into the footprint. They're not polarized. Alright, the next tallest thing is probably the pin header. See how it's sort of like scored? You can actually break this really easily with a pair of needle nose pliers. What we want to do is we want to count 6 and then just break it with the needle nose pliers. So there's our broken off header. For me, I have this little tiny clamp that I'm just going to hold it in place. Flip it around, and I'm just going to tack the first hole to make sure that it's nice and flat. And now I'm going to solder the rest of the pins. Okay, sweet. So now let's do the 3.3 microfarad capacitors. So as you can see, this is a polarized device. There's two leads on it. One long one, one short one. The short one is negative, okay? The long one is positive. So when we're looking at our board, we want to make sure that the positive lead goes into the positive hole and the negative goes into the negative. And then we need to pull our 100 microfarad capacitors. So same deal with these. It's got the negative marking, and that's going to go into our negative hole. Alright, so now let's attach our voltage regulators. The thing about voltage regulators is they get kind of warm as we hook things up to the power supply, like our ESP32S3, any of our powered peripherals, that kind of thing. This little guy here is going to get warm. So we're going to attach a heat sink to it, which is basically just a chunk of metal that helps it dissipate heat. Now I've seen this style attached like this, but the way that I've actually designed the board, or my board anyway, is I've made it so that the heat sink is attached to the back like that. And the reason for that is because I wasn't sure if this little heat sink was going to be big enough. This thing might still get warm. So, you know, I wanted extra space on the board. You know, for now, this is okay. So when you attach the heat sink, you get this little kit. It's just got a screw and some nuts in it, and then this little tiny piece of plastic. First thing you have is this little tiny plastic insert, and that goes into the front. Then you've got your screw that goes in like that. And then on the back of the regulator, you're going to put your piece of plastic. And this is just basically so that the regulator isn't directly touching the piece of metal like that. So we just put it on there, put on your washer, put on your locking nut, and your bolt. And then you tighten it down. There you go. So that's what we're going for, and we're going to do that with each one of the regulators. So when we look at our PCB here, the square pad on our regulator is pin number 1. So here's our 7912, and we're just going to insert it like so. We can just bend the leads over slightly there. It's not the prettiest thing in the world, but hey, that'll work, right? Here's our 7805, same thing, pin number 1, which is over here. Bend the leads slightly on the back just to kind of hold it in place like that. And finally, our positive 12 volt regulator. The leftmost pin is pin number 1, so we'll do that. And we'll hold it in place. Now let's solder these guys. All right, cool. So for those who've been watching closely, I switched side cutters because these ones are way sharper. Next up, let's put in the big capacitors, right? So remember, this is our negative lead, that's our positive lead. These are the ones that would really ruin your weekend if they exploded on you. So I gotta make sure that this lead here, the long lead, goes into the positive hole of this PCB, right? So positive there, okay. Looks good. Bend the leads. There we go. All right, let's get the rest of them in there. All right, cool. There we go. Looking good. Now all we have to do is hook up our wires so that we can plug in our barrel jack, right? So as you remember, here's our barrel jack soldered to a couple breadboard jumpers, and this is just super temporary for right now, right? Is we're going to solder these connections in the board here so we can attach our AC adapter for testing. This is just for development purposes, right? We're going to replace this with a proper gauge wire, and the barrel jack connector will have heat shrink on it, and it'll look really nice and be really good. So let's solder these on and then plug it in, and hopefully nothing blows up. There we go. There's the power supply for the S3-1200. I am really nervous. I hope this thing works. So, as you might remember from last time, here is our AC adapter. 12 volt output, 1500 milliamps. Let's do it. Let's plug it in and hopefully nothing blows up. We've got all of our LEDs on, so that's really good news. Phew. Let's take some voltage measurements. We're going to take our black lead, right? And we're going to place it where it says ground on the pin header. Take our red lead, place it where it says 5 volts. And we got 5 volts there. Now let's do 12 volts. There's our 12 volts and negative 12 volts. Nice. It works. So there you go. The power supply works. We got 5 volts. We got 12 volts. We got negative 12 volts. If you have any questions about this build, feel free to hit me up on Instagram or TikTok. If you're building along and you want to talk to other people who are building along, or other people who are just building other pieces of gear, join the Discord server. If you want to support the channel and download the schematic and design files for this power supply, join the Patreon. All the links are in the description. So in the next video, we're finally going to get to some good stuff. We're going to be hooking up the ESP32S3. We're going to talk setup and pin layout. We're going to install the software that we need to program the microcontroller. We're going to run a test program, and then we're going to power it up using our power supply. So if this is something that interests you, please subscribe to the channel. For those who have subscribed, I salute you, and thanks for watching. I'll see you in the next video.